Brother Corey, did you want to end the recording and start a second one? Also, your mic is still off.
How is everybody there? Yeah. Yesterday was an exciting day in our family. My son, who's a freshman here at BYU, got his mission call. So he's going to Korea, Busan. So yeah, anyone here serve in Korea? So Michelle, the TA for the 1 o'clock section, she served in Korea, Busan. So it's her exact mission. So he's really excited. He really wanted to go foreign. So, and or at least learn another language. He learned Latin in high school, but there's no place on the application to say that you know Latin, because it's not a useful language. You know, no missionaries out there speak Latin. But of course, there's a lot of languages connected to Latin, right? Like all the Romance languages of Spanish and French and Italian and Romanian and Catalan and Portuguese and all that. Okay. Who'd like to start us off with a prayer? Thanks.
Our beloved Father in heaven, we're very thankful for this day and for the opportunity we have to be on campus and for the protection that campus has been providing for us against the coronavirus, that we can meet in person and learn. But thank you for Brother Corey's preparations. Please bless that we can learn and what we need to learn today, and that we'll be able to remember it and continue our education. We say these things in the name of Jesus Christ. Amen.
Amen. Thank you. If you ever want to make a professor feel bad, you say a prayer and you say, thank you for all of the preparation that the professor has done. And then if they haven't prepared, they're like, oh, but I've prepared a lot for this lesson. So thank you for that prayer. Okay, here's homework over here. So this will be kind of typical, hopefully from here on out, of what your homework is. These three are all in preparation for the next. Right, you're going to watch the videos or study the rest of the slides for 2.2. You're going to read the rest of 2.2. There is a section, the last section is called Linear Systems in ZP. You don't have to read that. That's not something you're required to do. If you are in computer science, you might want to. That's one place where I can see you're most likely to bump into using that material. It's basically modular arithmetic in with matrices, integers with modular arithmetic, and then do the online work. So this is in preparation for the next stuff, and then do the written of 2.2 A, which is what we'll finish today. Any questions on this? Okay. Any questions on the reading or the online homework in preparation for today? The last class had lots of questions, so I'm sure you have lots of questions.
I mean, I'm sure we'll get to it, but I wasn't sure how to identify whether one was reduced or not.
Okay, that was a big question. That's why I put this up, because I knew other people would have questions. Okay, other questions besides, like, what's the difference between reduced row echelon form and row echelon form? And we'll talk about how to use them too. But any questions besides those? Yes.
I know it's not very used heavily, but the elementary row operations, there's sort of like a train of thought you want to go at it with?
Yes. Okay. Yes. Yeah, and we'll talk about that too. I can quickly throw up. That sounded bad. I'm not quickly going to throw. I'll quickly write up. What do you want to do? So usually you want to get this one a 1 first. So this is first. You get that a 1, and then you use that 1 to get this a 0. So that's second. And then use that 1 to get that a 0. And then, so that's third. And then fourth, you want to get this a 1 if you can. Yeah. Right? And then you come down and make that a 0. And then use this a 1 if you can. Because sometimes this whole row might be zeros and you're stuck. And then you go back up, 0, 0, 0. So that's, in general, that's the process that you do. Okay? Great. That's to get to reduced row echelon form. Row echelon form, you don't have to go that far. So, yeah. Other questions besides what's the difference, which we'll talk about in a second, And that, yes. Echelon. Yeah. ¿Cuál es el significado de la palabra escalera en español? Stairs or ladder, yeah. So I can't spell it. Is it E-R-A? Escalera? Is it A-R-A? E-R-A. So escalera is stairs or ladder. Okay, it's the same root. Like that's where we get escalator from. It's the same root for echelon. So it refers to levels, and you can see the levels in here, the stair step. So structure. So that's where that comes from. So okay, good question. Yes. But this would depend on your matrix. So not all the matrices will you be able to get zeros on the bottom. So. Yep. Yeah. It could. Yeah. If I had a 1 right here, or yeah, a 1 right here, that would be fine. So well, yeah. Like if this was a number here, that'd be great. If these two were numbers, that would still be row echelon form. So okay. All right. Well, since we're talking about these, let's go ahead. So row echelon form, the big rule is all the leading entries are to the right of any of the leading entries in the rows above it. Okay. So here I only have 3 leading entries. I do have a row of zeros. There's none here, so they have to be at the bottom. But all the leading entries, this is to the right of the leading entry, the one above it. This is to the right of the 2 above it. Okay. So that's your number 1 guiding rule. They don't have to be 1s. The leading entries don't have to be 1s. Okay. In reduced row echelon form, you still have the rule that that all the leading entries are going to be to the right of the leading entries in the rows above it. But all the leading entries have to be 1. And any other entries where you have any other entries in a column where you have a leading entry of 1, all of the other entries have to be 0. So, and one of the nice things about this is that reduced row echelon form is unique. Meaning, if you start with your matrix and no matter which order you do things, you can change the order and swap rows around while you're doing it. No matter how you get here, you'll always end up with this exact same thing. So, and that's nice because it tells you something about the whole structure of the system, the whole structure of the matrix, which will be important later on. So, okay. So this is not unique because I could divide this whole row by 2, end up with a 1 there and some other values. That's still in row echelon form. It's not in reduced row echelon form, but it's still a row echelon form. Yes?
So like on that reduced one, like the 3rd column, since there's no leading one in that column, then it's fine to have.
Yep.
So that's not 0.
Yep. Yep. That's still okay. Like these are okay because I don't have once you have these leading entries, these columns where you have leading entries, those are called pivot columns. And these are called pivot entries or pivot positions. So I should write that down. Pivot columns. So anywhere where you have a pivot column, you'll be able to use that 1 to make all the other ones 0. But if you don't have a pivot column here, we're going to be stuck, and we'll just have to let it be what it is. So, okay. Other questions? That's right. So in some sense, this is like as simplified as we can get. If it's really nice, then the reduced row echelon form, at least of an augmented matrix, if it's like a 3 by 3, once you get to this, if you can get to this, then you know exactly what the solution is of the system, because this would represent, well, we'll get to there, but yeah, this basically in a system of equations means I know x equals a, I know y equals b, and I know z equals c. So that's what we're shooting for, is something like this. But sometimes we might not have all the information we need, and here it turns out there's infinite solutions. So, but yeah, we'll talk about that coming up. But that's a really good way of thinking about it. Reduced row echelon form is like as simple as you can get, as reduced as you can get for a matrix. Okay, other questions? So if the point, it depends on the point on why you were doing this. But if you have a system of equations that you've put into an augmented matrix, then you interpret it like I just interpreted this to find your solutions. So running out of board space. So if I have 1, 0, 0, 3, 0, 1, 0, a minus 0.5, 0, 0, 1, a minus 2, then this in a system of equations is x plus 0y plus 0z equals 3, 0x plus y plus 0z equals a minus 0.5, 0x plus 0y plus z equals a minus 2. Well, this just tells me, hey, z equals 2, y equals a minus 0.5, and x equals 3. So I have the system of, I know the solution. So who asked that question? Did that help? Okay. All right, other questions?
What's the point of the zero line? Is it relevant in any way?
Yep. So if you end up with zeros here, it's one way of signifying that you have infinite solutions. So if you end up with 0 and like a number here, then you have no solutions. Because this basically says, if I don't have any x, y's, or z's, I still equal 5. Doesn't make sense. We'll talk a little bit more about that later. Okay. Other questions? Yes.
When you say later, you mean later today or later in the course?
Well, hopefully later today, if not tomorrow, for that one. So, yep. We'll talk about infinite solution. We'll talk about the graphing, what it represents graphically with infinite solutions today. We'll talk about representing them as a solution set with equations tomorrow or Tuesday. Okay. All right. So, I love to make money. Great. So I picked this topic just for you. Okay. So yesterday I went on to find three stocks. These are exchange traded funds, so they're actually not company stocks. They're a conglomeration of things. QQQ, it follows the NASDAQ index. NASDAQ are tech companies. SPXL, it follows the S&P 500, but it tries to triple the daily return. So if the S&P goes up 0.5%, then that day this would go up about 1.5%, which is great. But if it goes down, if the S&P goes down 0.5% a day, this goes down 1.5%. And this is a real estate fund, and it tries to double the real estate return. It follows a real estate sector index, and it tries to double what that index does every day. So these are percentages over the last, I think they're all 10-year. These are 10-year returns. 22% on average here, 34% on average here, 13% on average here. So that's the rate of return. These are betas. Betas are a measure of volatility, and this is bad. Okay, you'd love to have this high and this 0. That means you just always can basically be guaranteed to keep going up. Okay, but volatility is bad. That means you can lose lots of money fast, especially here. I've never dared buy that stuff. I look at it all the time. It's so easy to convince yourself, man, I could have made so much money if I would have bought that 6 months ago. But it's always easy The trick is knowing 6 months in advance when you should have bought it. But okay. And this is the expense to pay for these funds. It costs money out of your pocket. So when you buy it, how much does it cost? So these are the percentage. Like if you put down $10,000 here, you're going to lose 1.2% of that right off the bat. So you want this low. So you want this high. You want the beta low. This is a measure of risk. You want this low because it's money you lose right off the bat. So this is what financial advisors do, or financial or portfolio managers. They're trying to take different funds and combine them in different ways, different amounts, to get their ideal goal, to get their ideal set. Some will be more aggressive, so you're going for a higher return, and you'll allow it to be higher risk. Others will be more conservative. So our goal, this is my goal, okay? 21% return. I'll allow 1.5 on my beta as a risk factor, and I'm willing to pay 7%, or yeah, 0.7% for my expense. The question is there some way I can combine all these and actually get that? So that's what a system of solutions, a system of equations can help you find. Here I've written it down. This is using the ideas from the peanut butter book. It's natural to think like, how much of the QQQ, how much of the SPXL, and how much of the URE do I take to get my goal? Right? Sounds a lot like the peanut butter book. How much of the peanut butter, how much of the bread, how much of the jam, et cetera, to reach this. X is this amount. X is the amount of QQQ. Y is the amount of SPXL. Z is the amount of the real estate fund. Okay? So I can write it down this way. This just corresponds to a system of equations. So this, if I just do scalar multiplication, I could just rewrite that as 22x, 1x, 0.2x. I can do this as 34y, 3y, 1y, and 13z, 1.5z, 1.2z. And now I'm just vector addition. I just add up the components. And if I add up the components, I just end up with an equation equals this number. So the top equation, 22x plus 34y, 13z has to equal 21. So you can just start writing down these three equations. Okay? Questions going from here to there? Okay. This highlights thinking in packets here. This is where you can easily see the different funds. These equations this highlights your rate, this is your beta, and this is your expense. So one highlights the different quantities, and the other highlights the different packets. So this is moving into chapter 3, but we could rewrite this. We could rewrite this as a matrix and vector product. This is where we're going to be going in chapter 3. I did already talk about this in the peanut butter book. So I can rewrite this x, y, and z as a vector. They're my packet of unknowns. And then I can rewrite all of these values in this matrix. It's already right there. And the matrix multiplication is exactly this process. And the question is, what x, y, and z can I multiply by that matrix and get this value? So that's where we'll be going in 3. And we'll tend to just call big matrices a value, our x as a vector. So this is a vector of unknowns, and b as some other quantity. So, and this will allow us to find other ways to solve systems of equations and to understand systems of equations. So the point over the next couple of sections is to learn how to solve these things. A lot of you are really comfortable already. You've already done units in this in pre-calculus, how to solve system of equations. So for those of you that have done this, these aren't new. These are the 3 elementary row operations There are operations we can do, and they're important because they will not change the solution set. Okay, that's the key. If you switch the order of the rows, if I just write these down in a different way, have I changed what values x, y, and z will make these equations true? No, I haven't changed. If I just change the order, that's the easiest one. Of course, if I have any equation and I multiply the whole equation by a non-zero constant, have I changed the solution of the equation? You guys use this all the time. 2x equals 4. What's the solution? X equals 2. Why? Because you're going to multiply both sides by 1/2. Right? We do that all the time. We know it's not going to change the solution. The harder one to see is this one. Add a multiple of one row to another. So let me pull up. Do I still have it up? Oh, I do. I'm just going back to oops, I didn't mean 21. There we go. All right, here's here's a system of equations, 2 lines. You guys see that a little better? Graphically, we can already we can read off what the solution is. When x is 1 and y is a -1, then if I plug those 2 values in, then I make both of these equations true. Because anything along, what's this? So here's equation 1. Any coordinate, any xy coordinate on this line will make equation 1 true. But it won't necessarily make equation 2 true. They will only be true, both be true at this point. Okay? So what happens when we add a multiple of one row to another, or add a multiple of one equation to another? So this equation 3 is just adding those 2 together. So I have 3x minus an x gets me 2x. I have a -2y plus a y, that'll give me a y. Then 5 minus 2 is 3. What happened there? That equation still goes through this point. Okay? It did. It changes the slope. It didn't change the intersection point. And what we would like to do, what's really nice is if you change the slope so much that it's horizontal or vertical. That's exactly what you do when you do elimination. So if I take, if I multiply equation 2 by 3 and add it to equation 1, okay, so I'm doing 3 times equation 2 and add it to equation 1, that should eliminate my x's. That will eliminate my x's. So a -3 times x, add it to 3x, I get 0. So this is equation 4. If I take 3y's minus 2y's, I get a y. And if I take three -2's, that's a -6, add it to 5, I get a -1. And that's the equation of y equals a -1. So it still has the solution, that same solution set. It shares that with all the other ones. So as you're doing elimination, what you do is you keep one of your old equations and you replace it with a new equation. And they're always going to intersect there. The reason is you're just adding equals to equals, or you're subtracting equals to equals. So we know we can add, if you add the same thing to both sides of an equation, then it's still going to be a valid equation, right? You haven't changed the solution set. Here, that's true. It's true that this side equals this side, but that side equals that. The 2 sides are equal only at that point. Okay? Well, sorry, not at that point. Anywhere on that line. And here, again, this side equals this side anywhere on this line. And so if I add those together, or subtract, or do whatever those operations are, I'm just doing the same thing to one side that I am on the other side. they're equals, and so it's not going to change the solution set. Okay, not the best explanation, but graphically you can kind of see what's happening. Okay, here I have two equations, equation 1 and equation 2. Where did they go? They're the exact same line. Okay, it's still a system of equations. How many solutions do I have? Infinitely many. Any point on on one line will be a solution for the other line. What about this case? No, there's no solutions. There's no coordinate of x and y that you can plug into one and make it true, and plug those same coordinates into the other one and make it true. Here I have no solutions. When we're dealing with linear equations, I only have 3 options. Exactly one solution, infinite solutions, or no solutions. You can't have 2 solutions. You can't have 10. You can't have any finite amount. You either have 2, infinite, or, sorry, what? Just make sure you're paying attention. All right. 1, 0, or infinite. Okay. Because we're dealing with lines. Can you have 2 lines intersect and get 2? And have it intersect in exactly 2 spots? No. Yeah, so now, see, so once you get into nonlinear and you could have curves, then you could have multiple spots. Okay. All right, so we're going to use these elementary row operations, and we're going to start solving this system of equations. Okay. For those of you that are comfortable with this, you can go ahead and start solving this. I know some of you have done this a lot. Go ahead, have at it. I'm going to start doing it. And I'm going to show you something that might save you some time, at least rewriting. It's something that my colleague taught me about a month ago. So it's just a shorthand notation. Okay, so the first thing I'm going to do is I'm going to rewrite this as a matrix. I'm going to drop my equals. I'm going to drop my x, y's, and z's. It just takes a lot of time to rewrite those every time, right? I don't need those. And when I'm back at the very end, then I can put them back in. So we just really care about these numbers, these coefficients. And before I even write it down the first time, I am going to swap this. I'm going to swap these two. I'm going to swap my second one and my first one. Why might I want to do that? This has a 1 coefficient, and it's really nice if I can get a 1 right up here to begin with. So, in this, someone asked if there's a nice order. Yeah, when you start doing this, if you can make this a 1, your very first, then you can use that 1, and you can easily start getting rid of these things here. And it's sure you can divide. I could divide all of this by 22. But then I've got 34 20-seconds and 13 20-seconds and 21 20-seconds, and I don't want to be dealing with those, doing operations with those. So I'm just going to switch those. My hiccup ringing is coming out. I'm going to swap those. Okay. And here I've got a leading one. I've got a leading 1 here. I want to use this one to make these 0. So how can I make this 0? Which operation should I use? I can't switch order of the rows. I mean, if this was 0 right here, then I could do that, but I can multiply a row by a non-zero constant, so that's not going to help me. So I have to add a multiple of one row to another. So I'm going to take a negative 22 times row 1 and add it to row 2. That's going to be my new row 2. So I'm going to multiply this row by a negative 22 and add it to this. So I'm doing elimination, basically. So now if I multiply this by a negative 22, negative 22 times 1 is a negative 22, plus 22 is 0. A negative 22 times 3 is a negative 66. A negative 66 plus 34, that's going to, well, if it was a negative 36, it would be 30. But I'm only at 34, so it's going to be a negative 32. And a negative 22 times 1.5, luckily it's even. We end up with 33, a negative 33. A negative 33 plus 13, a negative 20. A negative 15 times, 1.5 times a negative 22 is another negative 33 added to 21, and I get a negative 12. Can you see how you could make a lot of mistakes doing this? Yeah. It depends. To do those calculations like I just did, sure. But your calculator, if you've got a fancy calculator, it'll do this for you, right? You can go to Wolfram Alpha, type in the whole matrix, and it'll have it reduce it for you. Yes? Right now, we're just focusing on row echelon. So this doesn't have to be 1, technically, but when it's 1, it makes it easy to do some of the calculations. So in practice, like all of you are going into technical fields, a lot of you have a high probability of bumping into linear systems. In practice, those linear systems can be extremely large, okay? Like hundreds of variables sometimes. You're not going to be doing this by hand. We do have you spend some time doing it by hand. One of the key things is once you do a few of these by hand, you can at least start the process when you look at a matrix and start to figure out at least how many pivot columns it has, which is a key thing. And so you can see, and whether the set is linear, independent, or dependent. It gives you enough mental tools that it's actually quicker to just do it mentally than to be like, okay, let me pull up a website and type it all in. So yes, in practice, you won't make mistakes. Well, you might make a mistake typing it into the computer, but you're going to have it do the system. But we do have you work through the algorithm a few times. Okay. And feel free to check your answer. Like use Wolfram Alpha or some other calculator tool to check your answer on these. I did this problem. It took me 3 times before I got the right answer by hand. So like it's just so easy to make mistakes. I dropped the negative sign once. And yeah, one time I went over and I stopped at this line and didn't do the calculation on this one. So it's just easy to do. So isn't that sad? So sad. But the last time I did this was probably before you guys were born. So, it's been longer for me than it has been for you. All right, what's the next strategy I'm going to do? I'd like to make this 0. Like this right here, it'd be nice to have 0. I have this leading entry. I need to have zeros below it. I don't like this 0.2 though. I don't like these decimals. It'd be really nice if these were whole numbers. Let's multiply by 10. So this will be 10 times row 3. So that'll be 2, 10, 12, 7. And then I rewrite again. Now, you can see it, rewriting takes a long time. So I'm going to show you guys a trick that can help. I'm going to write this down. So these are spread apart. And I'm going to just do the calculations. Where am I at? 0, minus 32. Minus 20, minus 12, 2, 10, 12, 7. I'm just going to do the calculations to the sides of these numbers. And I'll show you how to do this. So what I'd like to do now is to make this 0. So I'm going to multiply this row by a -2 and add it to this row. Okay? So I'm going to just write down in where the exponent, where an exponent goes, I'm going to write down the operation that I'm doing for each of these. So a -2 times 1 is a -2. And 3 times a -2 is a -6. 1.5 times a -2 is a -3. 1.5 is a -3. So before I just kept that number in my head. This way, I can see what I'm doing. See, each one of these numbers multiplied by a -2 are these numbers. And then I'm just going to write down the result next to it. 2 minus 2 is 0. So now that's my new number. 10 minus 6 is 4. Now that's my new number. 12 minus 3 is 9. That's my new number to deal with. 7 minus 3 is 4. That saved me from rewriting all of that again. Now, eventually it's going to get cluttered enough you're going to want to rewrite anyway, but it might save you a few steps. Okay. Now, what's the next thing I'd like? I have this as a 1 and I have these zeros. What else do I need for row echelon form? I need this to be 0. And I have a few options. I could, that's right. So I could divide by 8 here. So divide this by 8 and add. The only issue with that is I do end up with fractions. It's still okay, they're not crazy fractions. Okay. I could also multiply this one by 8. Instead of this by 1/8, I could multiply this by 1/8 and add those two together. So does that make sense? So let's do that. So I'm going to multiply this by 8 and add the 32. So I'm going to end up with, I'm going to write down both of these. So here I'm going to end up with a 32 minus a 32. Here I'm going to end up with, what's 8 times 9? 72 minus a 20. And here I'm going to end up with a 32 minus, what's 8 times this? 96? Oh, positive. I'm adding, yeah, so minus 96. So I end up with large numbers, but I don't have fractions. So, yes? Oh, did I make them, did I do it the wrong way? Dang it. I just added, my bad. I like multiplying by 8. You know, it's crazy 8s. Sorry. Okay, so 32 minus 32 is 0. 72 minus 20 gives me 52. And 32 minus, so this is a different order than I did last time. So on what I have in my notes. So, so doing it on the fly. See how easy it is to make mistakes? I have colleagues that, I have one colleague, he offers extra credit for any student that can catch a mistake when he's teaching in class. But if I did that, you guys would all get A's because I make so many mistakes. So now I have, see now I might rewrite this, or rewrite that line at least. So this is as far as we're going to go right now. So I'm going to just write 1, 3, 1.5, 1.5, 0, minus 32, minus 20, minus 12, 0, 0, 52, 20. What form is this in? Row echelon. Is it in reduced row echelon? No. How many pivot points do I have? 3. I have 3 pivot columns or 3 pivot points. Each of these is a pivot point. I can make these ones. I can divide by 52. Here I can divide by negative 32 and make those ones. And then I can use those ones to get rid of these, to make all of these 0. We'll work on that tomorrow to continue the process. Oh, sorry. Did you have a question?
No, sir.
Okay. Go ahead, Ian.
Reduced row echelon form, you have to go back up the other side and make all those zeros as well.
Yep. So, if you're after the solution, what the book talked about, once you get to this point, you can do back substitution. So we can translate this back into equations. X plus 3y plus 1.5z equals 1.5. A negative 32y minus 20z equals a negative 12. And 52z equals 20. So we're one step away from knowing what z is. So z is 20 divided by 52. Okay, you can simplify that. Before I go into both of those, 5/13. Okay, which is about 0.38. Okay, if you have your 13 decimals memorized. I'm just kidding, I already did this yesterday. I knew that's, it was 0.38. So here, we can solve for z, and now I can plug z back into this equation, and then I can solve for y. And then I know what y and z are, I can plug that into this equation, and then you can solve for x. So that's called back substitution. Yes?
What is the balance in terms of the stock? Why is it beneficial to have it?
Perfect. So the x, y, and the z, they are the amounts that I would buy for each one of these. So they're technically not the amounts, they're the ratios that I would use. So if I remember right, I think y was about 0.1 and x was about 0.9. So I have 0.9, 0.1, and 0.38. If we called that a ratio of 9:1, we'll just round up to 4. Then anytime I spent $9 on which one's my x? $9 on the QQQ, I'd spend $1 on the SPXL and 4 on the URE. You know, and if you're rich, you know, multiply all those by 10,000, and then that's what you have with your portfolio. So yeah, so that's what that solution means in this particular case. Yes. Yeah, so their importance, so in the reading that you'll do today, that'll introduce the idea of a rank, but it still doesn't motivate you. The book still doesn't motivate on why the rank is important. The number of pivot columns is the rank of the matrix. And one way to think about what that rank is it tells you the dimension that the dimension of all of the places you can get to with combinations of your columns. Okay, that didn't come across very well. But if we're dealing with, if I have 3 stocks, and if I have 3 stocks and I have three quantities for each of those stocks, if I end up with 3 pivot columns, that means conceivably I can get to any goal that I want. It will fill R3. It'll fill all 3 dimensions. There's some combination I can use with these. Now, in our particular context, we're limited because you usually only buy positive values of stock, right? So you can sell short. So those of you who know much about investing, you can actually, instead of buying to make money, you buy low and sell high. you can actually reverse it. You can actually sell someone else's stock, but you have to buy it back and give it back to them later. And that's called selling short. So if you think it's going to drop, that's what people do to try to make money. So we could even have these negative values. But the point is, mathematically, if I have 3 pivot columns, then I can get any value here. But if I only have 2 pivot columns, then I can only actually get to I can only get on a certain plane in three-dimensional space. So we'll talk a lot more later on over the next few weeks about the importance of those pivot columns and what they represent.
Is there a way to like find like a max like rate of return with like the lowest minimum for the volatility?
Yep, but you'll need to go to a finance class, and they have ways to do that. So yeah, they have. That's a lot of what their field will work with, like optimizing portfolio things to achieve high rates and minimal risks. So that's not me, unfortunately.
Is that the same optimization calculus?
There are some. So the optimization, there is a field called linear programming, and the optimization it's a little bit easier than the calculus stuff. If you're only dealing with linear combinations of vectors, then all of your all optimal points will only happen at vertices of intersections, and so you actually have just a finite number of points to check. But yeah, we can talk about that later. I don't think we actually cover that here. It might be in one of your labs. I don't know, do you guys in 215? I wonder if they have a lab on linear programming. But yeah, I wish I knew more about it. To be a good math teacher, I feel like I need to go get a degree in mechanical engineering and electrical engineering and computer science and physics and finance. I have a master's degree in statistics, so I know a lot about statistics. I'll be bringing some of that in, but I feel like if I knew all those fields really well, I could do a lot better at bringing stuff like that in. Okay, other questions with what we've done so far? Yeah, I'll tell you the answer. The answer is we'll talk about it later. That seems to be all the answers. I'm just kidding. Go ahead. Yes. Usually, yes, there is a benefit to doing. I don't have my row echelon form up, but the row echelon form for this would be. That's a horrible place to write that. I have it right here. It would be 0, 1, 1, 0. And this would be 0.38, 0.1, 0.9, whatever that is. Is it 0.5? Agreed. I can't remember what it was yesterday. So, so one advantage is we know exactly what the solution is. Okay, but something else that if you don't have one solution but you have infinite solutions, you're going to end up with something like this. And we can use this form to better describe what the solutions are, because okay, just saying there's infinite solutions, okay, that doesn't help me a lot. Show me where those infinite solutions are. What's the line that they lie on, or the plane that they lie on? And this we can get to them easily. We will do this tomorrow. Okay, so when you're in the infinite solution situation. You can. I think most students would find it easier to work it from here. So, yeah. Okay, good questions. Others? Okay. Oh, there's a question. Yes.
scope today, it was due at 2 p.m., not 1 p.m. But on Learning Suite, it said it was due at 1 p.m.
Oh, yeah. Some systems, some of our systems are combined with the other class. And so we have to pick one thing that works for both. So that's why it's 1 on some of them. But grade scope, I think we have you guys in different sections. So we can say it's 1 for one and 2 for the other. So did that make sense? So right. Yeah. So, okay. Have a great day.